Why do we focus so much on problem solving? Problem solving is a key life skill, not just for humans, but even for animals, but especially for humans. Sometimes survival depends on solving a particular problem. We solve problems individually as well as collectively. Our ability to solve problems is a skill, or rather a collection of skills that we acquire and hone throughout our lifetime. Some problem-solving techniques are domain-specific, and we typically learn them as part of the curriculum for that particular field. But even when we learn these domain-specific techniques, we also, at the same time, get better at solving problems in general, in all domains. Some fields of knowledge don't have an explicit focus on problem solving. For example, history. But that doesn't mean that they are completely unrelated to problem solving. Knowledge of history, for example, helps people who work in politics and international relations, or leaders of all other kinds, with solving the kinds of problems that they face. But mathematics, as well as the physical sciences and engineering, do have an explicit focus on problem solving. The word problem has two distinct meanings, which we are all well aware of. One meaning is a situation that is undesirable or unsatisfactory or causing difficulties, something that needs to be repaired or fixed. This type of problem could be called a real-world problem or an unwelcome problem. When we come across one of these, we sometimes wish it would go away. The other common meaning of the word is more like a puzzle, a challenge to uncover some piece of information that's been deliberately hidden. As in math problem or physics problem. To distinguish this second meaning from the first, these problems could be called textbook problems or puzzle-like problems. The first type of problem typically occurs on its own, while the second type is often constructed artificially for the purpose of education or even entertainment. Think Sudoku. We use both meanings all the time, and based on the context, we're intuitively aware of which meaning is being used, but we rarely consciously focus on the distinction. By the way, not all languages use the same word for both meanings. For example, when the phrase physics problem is translated from English into some other language, the word problem may be translated as something more like task. Incidentally, there's a similar situation with the word dream. In English, it has two completely different meanings. There's dream, and there's dream. But in some other languages, there are two separate words corresponding to the two senses of the English word dream. So when we talk about problem solving, the meaning of that phrase depends on which type of problem we're talking about. For unwelcome problems in the real world, it's something like identifying the root cause of the undesirable situation, then eliminating it or finding a way around it or reducing its negative impact. But for puzzle-like problems or textbook problems, solving them means completing the challenge and discovering the information that was hidden, typically by a step-by-step process. But not always. Sometimes there can be a sudden insight that cuts right through all the steps. The two senses of the word problem, unwelcome real-world problem and puzzle-like or textbook problem, are distinct but related, with puzzle problems there's a psychological discomfort in not yet knowing the answer, which helps motivate us to solve them. So in a sense, an unsolved puzzle is also an undesirable situation, in a sense, which begs to be fixed. And on the other hand, unwelcome real-world problems often present an intellectual challenge, and in that sense, many of them are puzzle-like, albeit not of the recreational kind. Although the two meanings of the word problem are distinct, and at first glance it may seem like solving recreational puzzles or problems from math and science textbooks will not help us with the vast majority of the problems we encounter in the real world. Nevertheless, there are deep connections between the kinds of thinking involved in solving both types of problems. Cognitive techniques, mental shortcuts, ways of asking questions, ways of conceptualizing and analyzing the information involved. And because the underlying mental processes are similar, it means that when we get better at solving puzzles and textbook problems, we are also building the mental skills for solving real-world problems. Sometimes we say that this person thinks like a mathematician, or that person thinks like an engineer, even when they're dealing with some seemingly non-technical matter, unrelated to science or engineering. They seem to view a problem through a quantitative mental prism. They seem to be able to grasp the essence of the problem intuitively, and then somehow find a particularly elegant or a particularly efficient solution. And the reason why this person thinks like a mathematician or that person thinks like an engineer is not because they were born an engineer or a mathematician, but because they were trained as a mathematician or an engineer. Even though some accomplished thinkers in the past and today were and are self-taught, there's still a learning process involved. With or without a teacher, inside or outside the classroom, we're not born with these mental skills. We learn them. In mathematics and the natural sciences, especially physics, students are expected not just to passively absorb information or merely memorize theories, concepts, laws, and formulas, but to learn how to apply them. There's a focus on learning by doing. And in practice, this means primarily learning how to solve problems. These problems are, of course, the textbook type, artificially constructed puzzles, meant as a challenge to uncover some hidden information. They're not real-world undesirable situations that need to be dealt with urgently. But getting better at solving textbook problems can be a stepping stone towards getting good at solving real-world problems. And in engineering, the two meanings of the word problem come together in a way. Engineers solve math problems and physics problems and chemistry problems in order to create improvements in real-world situations that are unsatisfactory in one way or another. Not everyone taking a science or engineering course in school is going to become a scientist or an engineer. But the value of a science and engineering education goes far beyond that, because ultimately it makes us better problem solvers in all aspects of life.